Hi, this is Dr. Kunka Bheemalingappa, Faculty of CSC. I heartily welcome you. In this video, I am going to discuss about the basic difference between delta and delta star in finite automata. These are the contents that what we are going to discuss. Difference between delta and delta star with respect to NFA, DFA and epsilon NFA. Yeah, you are known what is NFA, DFA and epsilon NFA. NFA corresponds to non-deterministic finite automata. First, let us see the basic difference between delta and delta star with respect to NFA. So, if I use this delta as the transition function, delta star of Q on epsilon is Q itself, and then delta star of Q A, that is some input symbol say A, is delta of Q A. I am talking these things about that is NFA, non-deterministic finite automata. So, for some y belongs to sigma star and A belongs to sigma, this delta star of QYA, delta star of QYA can be stated as follows, is equals to union of, being this is NFA, R belongs to delta star of QY delta of R A. So, delta star of QYA is this, del of delta star of Q Y A. You just remember delta star of Q on epsilon is Q itself, and for one input symbol there is no difference between delta and delta star, that is delta star of QA is equals to delta of QA, or we can say delta of QA is delta star of QA. If you have say, if it is a string, not just a single input symbol, then it can be stated as follows. For y belongs to sigma star and A belongs to sigma, A is a single input symbol and y is a some string belongs to this language, then delta star of QYA is del of delta star of QYA. I think it is clear. But when I take an example, you can get more clear about what is this delta and delta star. So, this is about the basic difference between delta and delta star with respect to this NFA. In a similar fashion, now we are going to look at with respect to this DFA. You are known DFA stands for what? Deterministic finite automata. DFA stands for deterministic finite automata. So, the difference between delta and delta star with respect to this DFA is as follows. So, delta star of some state say Q, delta star of Q YA for Y belongs to sigma star and A belongs to sigma can be stated as follows. Delta star of QYA is delta of delta star of QYA. QYA. That is, A belongs to sigma and Y belongs to sigma star. And also you make a note of that with respect to this DFA, delta star of Q epsilon is Q itself. This is true even with respect to this NFA. We have taken delta star of Q on epsilon is Q. So it is same with respect to both DFA and NFA. And the basic difference between NFA and DFA you are known. NFA in the transition table of NFA you will have multiple entries. Therefore, you have this union with respect to the definition of this NFA. Whereas in case of DFA, the transition table will consist single entries. Therefore, you are not going to have this union with respect to this DFA. With respect to this DFA, I think you are clear. So, if you have some, already I have shown this one for here. Suppose your Y is, suppose you have a string delta star of Q, say ABC. How it is going to be processed with respect to this DFA is as follows. First you have to write del of delta star of, after this AB is processed, you are going to read this C, right? So delta star of QAB, and then C. So this can be rewritten as what? Let me use a different color. So now in a similar fashion, how you have written this delta star of QABC? You can write delta star of QAB. The rest of the part as it is. That is, this part is same. Del of, what happened? Yeah. Del of, for this delta star part, that underlined part, right? I am writing. What is this? Is this? If you want to use a different color, you can use. Yeah, delta star of QAB can be written as what? In the same fashion. Del of delta star of QA and then B. This is what I have written for this delta star of QAB. And the rest of the part, it follows as it is. That is comma C. I think you have understood this. In a similar fashion, let me change this color. I am going to expand this delta star of QA. With respect to this NFA or DFA, you are known delta star of QA is delta of QA itself. Let me write here. Delta, that is for single input symbol, delta star of QA is no change with respect to single input symbol. Yeah. Delta star of QA is delta of QA. There is no difference with respect to a single input symbol. Therefore, in the NFA also I have written this with respect to a single input symbol. That is this. Delta star of QA is delta of QA. So this is true even with respect to this DFA. Delta star of QA is delta of QA. Okay, no change with respect to this. So now if you want to replace this delta star, being they are equal to one another with respect to a single input symbol, your known delta star of QA is delta of QA, right? So if you want to replace this, you can replace. Rest of the part is same. So del of, in place of this delta star, you can take it as just del. That is delta of QA, and the rest of the part as it is. B, close parenthesis, comma, C, close parenthesis. So that is what this delta star of Q, A, B, C. So delta star of, so this is parenthesized expression, right? First, innermost part it is going to get evaluated. First you are going to know what is this, okay, delta of QA. And then you are going to know what is this delta of QAB. This one you are going to get. And when you apply this delta for this part, you are going to get complete thing. That is delta of QABC. I think I understood. So this is the basic difference between delta and delta star. Don't get confused about this delta and delta star. So delta is this, delta star is this. That is Q by sigma gives Q. Q by sigma gives Q. Delta star means Q by sigma star. That is the only difference that you can find. Q by sigma star gives, that is Q. This is true even with respect to what? NFA. With respect to NF also same thing. This is the basic difference. So star means 0 or more instances. 0 or more instances. Sigma in the sense you are going to take some input symbol belongs to that input alphabet. That is what. I think I understood what is this. What is the difference between delta and delta star with respect to NFA and DFA. Now let me take one example for some regular expression. What is this NFA and DFA for that given regular expression? Suppose you have a regular expression, say A or B star ABB, A or B star ABB. This is the expression. You are known. What is the language that is described by this regular expression? 0 or more number of A's and B's of any combination followed by ABB. Every string must end with ABB. You are known what are the possible strings of this language. This first part, if I treat this as, okay, if I am going to break down this complex expression into two sub-expressions, say R1 part is A or B star, R2 part is say ABB, then this R1 part is optional, being you have that is a star. Star means 0 times. So you are not going to take any input from that, okay, R1 part. So then this is a string, right, that what you are going to get, ABB. You are known every string must end with here what, that is, okay, ABB. Every string must end with, that is, ABB. Because for this ABB you don't have, that is, star, right? That is compulsory part. So the other possible strings generated by this, you can have what? Any number of A's and B's of any combination, right? You can have just A or say just B or like AB or BA or like any combination ABA, any number of times. So from the R1 part followed by what? That is R2 part. R2 part is what? That is ABB. So every string must end with what? That is ABB. So these are some possible strings of this language you are known. Now if I take NFA for this regular expression, it looks like this. Suppose if I take this as a start state, let me take Let me give the number. For states, I am using the numbers to avoid the confusion from input alphabet. In the input alphabet, you are using letters. So for states, I am using numbers or digits, right? So this is A or B, any number of times, must be followed by what? A, let me give the number for this state as 2. This is input symbol B. This is state 3. And this is another input symbol, that is B, ABB. This is the transition, this is a NFA. This is the transition diagram of this NFA. This is the transition diagram of NFA. Yeah. And now we look at what is this delta and delta star with respect to this. You are known for a single input symbol, delta of QA is delta star of QA, and delta star of Q on epsilon is Q itself. Delta star of Q on epsilon is Q itself. And if you take a transition table, okay, for this NFA, it looks as follows. You are known what are the input symbols that what we have. Input symbols are AB. States are 1, 2, 3, 4. 1, 2, 3, 4. And you are known 4 is a final state. 1 is a start state. Final or accept state. So 1 on A, you can go to 1 or 2. 1 on A, you can go to 1 or 2. 1 on B, you can go to just 1. 2 on B, you can go to 3. 3 on B, you can go to 4. This is the table which corresponds to this. If I take some string which belongs to this language, suppose if I take this string, delta star of Q ABB, always starts from the start symbol. You are known the start symbol for this NFA is what? That is a 1. That is a 1. So delta star of 1, if I take some string say ABB, how it is going to be processed, right? It is as follows. Delta star of 1 ABB is what? Del of delta star of 1 AB and then B. Yeah. This is what this. I can rewrite this as what you are known. Del of delta star of 1 A B and then this is as it is B. So you have now single input symbol. You are known for single input symbol, there is no difference. Delta star of QA is equals to delta of QA. If you want to replace that, right, you can replace. So this is the transition function. That is a delta, right? So delta star of Q1A can be rewritten if you want. That is delta of 1A. So if you want me to rewrite, you can rewrite. Otherwise, I can erase this part directly. Delta of, in place of star, just you are writing A. B and then B. This is what we have. And you are known delta of 1A is what? From this one, what you are going to get? From this one, what you are going to get? Delta of 1a is, you are going to get as what? 1, 2. This is NFA, right? For a given state and input symbol, you can have more than one outgoing transition. So from state 1 on reading A, I can go to state 1 itself, or I can go to state 2. That is the reason you have got, that is 1, 2. Next, what you are supposed to do? You have to find 1 on B, and then that is 2 on B. So let me, where shall I show this? I can erase this part. That is the string I have taken. Yeah, for the string, you are known what is that string I have taken. ABB, right? So that is this. Let me erase even this part so that I can show you clearly. So the processing starts with what? That is the start state. Sorry. And you are known what is the start state here? That is a 1. So from the 1 is the start state. From 1 on reading A, where you are going to go? Either you can go to 1 or you can go to 2. From 1 on reading first input symbol A, you can go to 1 or you can go to 2. From this you have to continue. So 1 on B, where you are going? Next. So 1 on B, where you are going? Do you have a transition in the table? 1 on B, you can go to 1. So this is a 1. 1 on B, where I can go? I can go to 1 on B, I can go to 1 itself. And you are known what is your second input symbol? That is B, right? Yeah. So 2 on B, where you can go? 2 on B, right? You can go to 3. So that is this. 2 on B, you can go to state 3. State 3. So the first 2 input symbols AB are completed. You have to take into consideration that is the next input symbol. So 1 on B and 2 on B. 1 on B, 2 on B. What you have got, you are known for this part. What you have got? 1 on B is 1 itself. 2 on B you have got, that is 3. So from this transition function you have got. So after reading this input AB, you are there in the states 1, 3. You are there in the states 1, 3. Next you need to continue. What is your next input symbol? That is B. So 1 on B and also 3 on B. So from 1 on B, where you can go? From 1 on B, you can go to 1 itself. 1 on B, you can go to 1 itself. From 3 on B, where you are going? 3 on B, you are going to state 4. 3 on B, you are going to state 4. And you are known, this state 4 is a what? Final state. State 4 is a final state. That is 3 on B, you are going to this state. You are known how this ABB, it is going to get processed. How this ABB, it is going to get processed. So from start state on A, you can go to the state 2. And then from state 2 on B, you can go to state 3. On reading second B, you can go to state 4. So this is how this ABB it is going to get accepted. So you have to take into consideration the path which ends with this final state. So this is the path that it is going to take, and this is going to be ignored by this machine, right? ABB can be processed right in this fashion. A, B, again B. But this is not a final state. This is not a final state. So you have to take into consideration which ends with what? That is final or accept state. So that is ABB. It is going to get processed in this fashion. I hope now it is more clear to you. What do you mean by delta and delta star? So with respect to one input symbol, there is no change at all. But if you have say more than one input symbol, then you can find some difference. I think you understood that. So this is with respect to this DFA. Let me show the same thing with respect to, for the same regular expression, with respect to say DFA. In a similar fashion, you can take any string. This is a minimum string whose length is of that is 3. Every string must end with ABB, you are known, right? So in a similar fashion, if you want, you can try out for some other string like ABB or say B, ABB or anything. It is up to you. Next, moving on. For the same expression, if I am going to take DFA, you are known, right? What is the expression I have taken? ABB. If you want for the DFA for the same expression, I'm going to take. So the DFA for this expression is this. You are known, how to write. So this is a start state. Let me label this as what? A. Say 1. Let me label as this. Directly I am writing. You are known the procedure how to convert NFA to DFA, or say how to directly get DFA for a given regular expression. I'm not, but I'm mainly interested here in knowing the difference between delta and delta star. A, B, B. Let me give the number for this state as 3 and the number for this state as what? 5. And this is a final state. Let me use a different color for double circling. Yeah, this is your final state. So next, what I can do is, for A and B, I am taking different paths. That is, this is A, this is B, and let me give the number for this state as say 5 on B. You can go to state 5 itself. On reading A from this state, you can go to state 2. So from 3 and 4, you don't have transitions on input A. So if at all you come across A from these states, you can give a transition to this state. This is A, and with respect to with respect to this 3, you have transitions on both A and B. Also with respect to 2 and also with respect to A, 1, but you don't have transition from 4 with respect to the input symbol B, outgoing transitions, that is this. So this is a DFA. Say language is same. There is every string must end with ABB or any combination of any number of any combination of A and B's followed by that is ABB. So if you construct the table, this is what DFA I am saying. This is a DFA. This is a DFA which corresponds to this regular expression, that is this. First, let me write a transition table. You know the basic difference between NF and DFA. So this is the table. Your input symbol is A. Input symbol is B. States are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You are known. 1 is the start state. Here 4 is a final state. 4 is a final state. Okay. 1 on A where you can only outgoing transitions. This is outgoing. 1 on A you can go to 2. 2. 1 on B you can go to state 5. Shall I write the entries in the table with a different color? Yes. That is 2 and 5. 2 on A, outgoing transitions. This is incoming with respect to this 2, right? You know what is incoming and outgoing. Leaving from the state is outgoing. Coming towards the state is incoming. I think you are more clear about that. Yeah. So in the table, you are supposed to write only outgoing transitions. 2 on A is 2. 2 on B is 3. Next, with respect to 3, 3 on A is 2. That is this. 3 on B, you can go to state 4, you are known. In a similar fashion, 4 on A, outgoing transition. That is, you can go to state 2. Sorry, 3 on B I have not marked. 3 on B is 4. Not getting, okay. I'm trying to write, but it is not reflecting. Yeah. 3 on B, you can go to state 4. 4 on A, you can go to state 2. 4 on B, 4 on B, you can go to state 5. 5 on A, you can go to state 2. 5 on B, that is 5 itself. This is the transition table. You have got single entries in the table. Single entries in the table. In the sense it is DFA, right? So now let me, I have discussed about this transition. There is difference between delta and delta star with respect to this DFA in second slide. Okay, let me quickly move to that and show that. Yeah, this is NFA. Yeah, with respect to this DFA is. With respect to this DFA, it is this. What it says, delta star of Q epsilon is, that is this, Q itself. Delta star of QA is equals to delta of QA. No change with, you don't find any difference at all with respect to a single input symbol. A is a single input symbol. A belongs to sigma. So delta star of QA is delta of QA. Right? For Y belongs to sigma star, and if which is followed by A, then we can find some difference. So delta star of QYA is this. Del of delta star of QY and then A. So first Y part you have to find what is this delta, and then for A part you are going to find. With this assumption now. So being this is a DFA, you are known. What is this DFA? Delta is Q by sigma gives Q. That is set of states. You know the basic difference between NF and DFA. Here in NFA you will have that is 2 power Q. Here you have that is just Q. That is this. Delta star is this. Q by sigma star gives that is Q itself. Yeah. You are known. What are the possible strings of this language? Some possible strings of this language. Every string must end with ABB. You can have any number of A's and B's of any combination followed by that is ABB. Followed by this ABB. Let me take some string belongs to this language, say AABB. You are known this is a string which belongs to this language. So if I take this string, how it is going to get processed? That is You are known what is the start state here is, that is a Q. What is the start state here is, that is Q. So delta star of, what is the start state? That is 1. AABB. AABB. How it is going to get processed? That is this. Del of delta star of 1. First, you have to process this AAB, and then you are going to get for that, okay, B, right? So first you have to find for AAB, and then for this B you are going to get. That is, so I can treat this AAB part as, yeah, first let me write here. You have this, right? AABB. So here I am going to treat this AAB as Y, and this is single alphabet, that is delta star of Q. You are known delta star of QYA is what? Del of delta star of QYA, that is this. Delta star of QYA is what? Del of delta star of QYA. I think I understood this. I could not. Yeah. So now you can, this can be rewritten as what? For this delta star part, you have to rewrite this. Or this, what is this delta star part? It says that is this. Rest of the part is same. Yeah. If I take this part outside, just a second. This is equals to this part same. Del of B part is same, that is B. So for this delta star, del of delta star of 1 AA comma B. This is for this part. Delta star of 1 AAB is this. Delta star of 1 AA on B. And this rest of the part is as it is, you have to write. That is this. Do you want me to use a different color? Yeah, that is this part is as it is. So that is comma B. So you are known how it is going to get processed. First it is going to read A, and then second A, and then B, and then that last B. So in this fashion it is going to get processed. So delta of, so this delta star part you are going to rewrite. That is this. For this you have to find once again. So delta star of 1 AA can be rewritten as what? Del of delta star of 1 A comma A. You are known this. Delta star of QYA is del of delta star of QYA. So in this fashion. So for this delta star part I have written, and the rest of the part is as it is. You are known what is the rest of the part here. That is this. Comma B. Comma B. That is what this transition function. So you can cross check, okay, how many opening parentheses are there, how many closing parentheses are there. 1, 2, 3, 4, right? So 1, 2, 3, 4. So this is how it is going to get processed. Now you are known with respect to NF and DFA, with respect to one input symbol, delta star of 1A is what? Delta of 1A. Delta of 1A. So without rewriting, just shall I erase this star? I think you won't get confused. Being since delta star of 1A is equal to delta of 1A. So directly I am reflecting here, right? Fine. Next, you are known delta of 1A. Delta of 1A is what? From 1, let me show here, that is. Here you will have only one outgoing transition. So from 1 on A, where you can go? You can go to 2. That is what this. On reading first A, you are going to be there in the state 2. So for this part, what you have got? That is 2. And then delta of 2A. So from 2 on reading, from the table also, yeah, 2 on A, where you are going, that is 2 itself. 2 on A you are going to, from the diagram, or 2 on A you are going to 2 itself. 2 on A you are going to 2 itself. So for this part, what you have got, once again, that is 2 itself. And then delta of 2B. 2 on B, where you are going, that is 3. 2 on B, where you are going, that is 3. So for this, what you have got, delta of 2B, in the sense, you got it as what? That is this 3. And delta of 3B this time. Delta of 3B is what? That is a 4. 3 on B, where you are going, that is 4. 3 on B, you are going 4. So this is how it is going to get processed. So how this string ABB, it is going to get processed, in the sense, it is as shown here. That is let me, yeah, B. That is how it is going to get processed. I think you have clearly understood what is the basic difference between delta and delta star with respect to NFA and DFA. The same explanation follows for epsilon NFA. The same explanation follows for epsilon NFA. So you are known the transition function of this epsilon NFA. Epsilon NFA. Just it is a recall. So by means of this, you can clearly understand the basic difference between epsilon NFA and other two, that is NFA and DFA. So what it says is this: delta star of Q on epsilon is what? In case of NFA and DFA, delta star of Q epsilon is what? Q itself. Delta star of Q epsilon is Q itself. If you want, you can, I have written that very clearly. Yeah, first statement. Delta star of Q epsilon is Q itself. That is with respect to NFA. In a similar fashion, with respect to DFA, where I have written this definition of this DFA. Yeah. Delta star of Q epsilon is, that is this, Q itself. Is that clear? Next. Now we are talking about this epsilon NFA. So the delta star of Q epsilon is what? Epsilon closure of, it is not just Q, but it is a epsilon closure with respect to this epsilon NFA. Is that clear? So in the same fashion, delta star of Q YA for Y belongs to sigma star and A belongs to sigma. And you are known, delta star means what? Delta means Q by sigma I am taking. Delta star means Q by sigma star. Q by sigma star. That is the basic difference. So delta star of QYA is epsilon closure of union of R belongs to epsilon closure of Q. R belongs to epsilon closure of QY delta of RA. This is the definition of this epsilon in FA1. So already I have given the difference between delta and delta star with respect to NFA and DFA. So the same explanation follows even for this epsilon NFA. For single input symbol, delta star of Q A is equals to delta of QA single input symbol. But if you have two or more symbols like this, then delta star, for example, if you have say delta star of QYA is equals to, let me write here, say QYA is equals to what? You have to find first, there is delta star of QY. First, after finding for A, you have to find for that is A. So that's all. Thank you for watching my video. Wish you a good day.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.